Okay, so part 2 has 7 questions. They're all worth 2 points. You want to make sure you show enough work because any mistake will cost you a point. So you want to double, triple check these because any one single mistake will definitely cost you a point. Even if it's a silly mistake and then a rounding error, we have to take off both of the points. So that's really, really bad. It says use a compass and straight edge to construct an inscribed square in circle T as shown below. Now I don't have an actual compass here. Obviously it's hard to do this on this paper and then get it on there. So I'm going to estimate and I'm going to do a really terrible job of it, but I'm going to show you the steps. What you can do is linked in the info in this video is a link to full construction videos with paper and a compass so that you can see those things. So that's all right. If you want to go there and walk through the steps of every construction or any construction that you want to look at, you can walk through those steps if you need to. So I'm just going to kind of estimate here. I apologize for that, but we don't have really the right tools on a computer to do all of the things that we would like to do. So I'm actually going to try this drawing tool one more time and hope that I can get this drawn in here. The very first thing that you want to do is draw a diameter because we're going to get a circle. And of course it's highlighter, you know, of all the things, right? I'm going to try to change that tool. I know it's probably not going to work, but that's okay. So then what you want to do is you're going to construct a perpendicular bisector. So to the best of my abilities, I would start, you know, here, or at, and I can't switch the pen now. Now it's being cranky. Okay, so I would start at the end, and you want to make the radius of that a little bit more than halfway. So measure out more than halfway and swoop up. So you're going to swoop up and do your crisscross, right? And swoop down. I should probably scroll down so you can see my little swoop down. Okay, so swoop down. Okay, to the best of your abilities. Then use that same measurement and start on the right. Use that same measurement and swoop up from this end point of the diameter and swoop down from that end point of the diameter. So now I have hopefully what will be my perpendicular bisector. So let's see here. Let's see if I can get this line to work. Let's choose that, and then let's see if I can change the color. Nope, it didn't work. Through that point. Oh gosh, that was not quite right. Sorry, let's undo that. That wasn't my best work, you think? Anyway, you're gonna have the perpendicular bisector through there. So, it's just off because it's the computer. Great. So this should be a little bit more over, and there we go. It should go right through those points, right? Let's pretend it actually makes it through T. Just make that a little bigger. All right, you should not do that on your exam. And then what you have is 4 points. You have 1, 2, 3, 4. Because those are 2 diameters, and that's the perpendicular bisector, those 4 sections are the same. So what we have here is a square. You would use your straight edge. Mine is terrible. And you should leave all construction marks. So all of that mess that I made, I'm just going to leave it there. Okay, let's talk about number 26. I'm going to change my marker. It's a terrible marker. The diagram below shows parallelogram, so we know all the things about a parallelogram, with diagonal LN. Angle M is 118, and angle LNO is 22. Explain why LNO, okay, is 40. Well, the first thing I know is that as soon as I see parallelogram, I start doing this. 118, 22, right? Well, then I really know this angle and this angle because that's a triangle, and in a triangle they add to 180. The angles add to 180. So I'm going to go to my calculator, which I can't seem to grab, and I'm going to say 118 plus 22. So 180 minus 140 is obviously 40. So wow, that's really great. I did it, but I'm supposed to explain. So I have to actually say all the things I thought. So let's go through this idea process. So how did I know angle O was 118? Well, in a parallelogram, opposite angles are congruent. So the measure of angle LON is equal to the measure of angle LMN, which is equal to 40 degrees, or is equal to 118 degrees. Hello. I just wanted to be at the end, huh? 118 degrees. All right. Then I knew that this was 22 because that was given, right? Then I just knew that in a triangle, they have to add to 180. So in triangle LON, the angles must sum to 180. Since the measure of angle LNO is 22 degrees, the measure of angle LON, there we go. LON is equal to 118 degrees. The measure of angle, what do they call it? NLO equals 40 degrees. And I've explained that pretty thoroughly using what I know about triangles, what I know about parallelograms. So that should be perfect. So figure it out, but say all of the things that you thought about. What statement did you make in your brain? You just have to write it out. We need to see your thought process. Very thirsty. All this talking is making me thirsty. All right, so the coordinates of the endpoints of AB are this and this. Point P is on AB. Determine and state the coordinates of point P such that they are in this ratio. This is a big deal. This is partitions, right? If you have the graph paper, use the graph paper. You're better visually than you are in any other fashion. So I actually have to scroll down here. So -6, -5, and 4, 0. -6, -5. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's A. And 4, 0. So 1, 2, 3, 4, 0. Oh, of course, B. All right. So they're saying that they want this in the ratio of 2 to 3, which means that there are 5 parts. We want to break this into 5 partitions, 5 pieces. So I'm actually going to count all the way up A and then over to B, up from A over to B. So basically kind of like slope. So up 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up 5 and then right 10. So if those have to be broken into 5 parts each, that means I'm going to go up 1 and right 2 for each piece. So from A, up 1, right 2. 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 And they're saying that A to P is 2 to 3 with PB. So P has to be 2 partitions from A. So 1, 2. P is this point. I would just label it right here. -2, -3. And we should draw the segment. So there we go. I've shown all of my thought process here. I have my solution on my graph, and it's over. So easy peasy, right? Okay, so, oh my goodness. The diagram shows a ramp. This is like a classic trig question, so I see this and I get happy. The diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.7 feet from the ground to the top of the loading platform. Determine and state to the nearest degree the angle of elevation. Fun fact, angle of elevation is formed with the horizontal and the diagonal looking up. So this is our angle of elevation. I'm going to call it theta because I know you like to call everything x, and I like to call everything that is an angle, I like to call theta. So looking at this, I know the opposite side from theta, and I know the hypotenuse in relation to that triangle. This would be what we call the adjacent side. All right, we want to find the angle. So I know the opposite, and I know the hypotenuse. So I have to write this out. SOHCAHTOA. If we're going to have something that relates the opposite and the hypotenuse, we're going to use sine. So sine of theta is equal to the opposite side, 4.5, over the hypotenuse, 11.75. Now, don't do anything. Freeze. In order to solve for theta, I need to undo sine. To undo sine, what I actually need to do is use its inverse. Sine inverse of sine theta, and what I do to one side on the left, I must do to the other on the right. So sine inverse of 4.5 over 11.75. So theta is going to be equal to whatever my calculator says that is. So let's go to our fancy calculator. Sine inverse is on this trig button. Looks like this. And I'm going to get a fraction, control divide. 4.5 over 11.75. So 22.5183. Let's see what they want me to round to. Theta. Hello. Okay, there we go. 22.5. Oh, 5183. Okay, they want me to round to the nearest degree. So that would be 22. The 5 tells me to raise. So theta is 23 degrees. Now, fun fact, if your calculator was not in degrees, you're not going to get that answer. So if you had a hard time getting that, check this up here. That should say degrees. If it doesn't, you can go to the settings. So home 5.2, you want to make sure it says float in degree. Okay? Those are fun little facts for you. All right, so now we have a circle. So this is an area of a shaded sector. And I believe you have two formulas, and either one will work here. You can use the radians formula or you can use the degree formula. That's okay. So I'm actually going to use, I secretly like the radians one better, but I know your brain works in degrees, so I'm going to use that one. It says in the diagram below, the area of the shaded sector, AOC, is 12 pi inches squared. And the length of OA, also known as the radius, R equals 6. Determine and state the measure of angle AOC. Yeah? So area of a sector, you have two formulas. You have one that's in radians and you have one that's in degrees. Area of the sector is just a portion of the area, agreed? So area of a circle is pi r squared. Well, I just want a portion of that. I want some measure of an angle out of the 360 portion of that area. So that's what the formula says. It says theta out of 360, this fraction of a circle, pi r squared. It's really all the formula says. We know that the area, the area of the sector is 12 pi. We're solving for theta over 360, and we know that we have a radius of 6. So I can plug all of that in. And let's see here. I'm going to have 12 pi is equal to, this is going to be 36 pi. And then I have theta over 360. I'm going to guess that you are not comfortable with that. So go here. And we have, I got to look at my paper because now I don't remember what I wrote. Doc B here really quickly. What is it? 36 pi, control divide, 36 pi over 360. And then theta is the only thing we don't know in that side. Okay, yeah. Just checking. So we get crazy number, right? 0.314, oh, kind of looks like pi, but all right. So 0.314, blah, blah, blah. And we're going to divide this side by that number, right? So we're going to divide this, both sides by this. Now, I'm going to show you how I'd really do it in just a second. So I'm going to go back here, 12 pi divided by that. So 12 pi divided by, and you can do control answer because you don't want to round, is 120. So 120 degrees. So that means that 120 degrees is equal to theta. I'm not going to use this pen anymore because I don't think it's dark enough. Anyway, this is kind of wacky. So what I would actually do is do 36 divided by 360 is 1/10. And then I would actually divide it over and cancel the pi's. So FYI to you. So that should be it. If you did this in radians, you would use the formula. Hold on, let me write it down for those of you. You would use, what is it? Theta over 2 pi, pi r squared. But the pi's cancel. So area of the sector would be theta over 2 r squared. So 12 pi equals theta over 2. 6 squared is 36. So 12 pi equals theta over 2 times 36. Half of 36 is 18. And then we'd have theta. So we would divide by 18. And we would reduce this in our calculator. So we would reduce this part. And we would get, oh, well, we would reduce that. I had a different number there before. So 12 over, so I should show you, control the divide, 12 over 18, and then just stick the pi on top. So I hope you know that 0.6 repeating is 2/3, 2 pi over 3, hello, 2 pi over 3 is equal to theta. So either way, you can get the correct answer. Both answers were accepted. Be careful if they specify in degrees or in radians, then you have to use the appropriate formula or at least know how to convert in the end. All right, so let's do part 2s. Woo. After a reflection over a line, triangle A prime, B prime, C prime is the image of triangle ABC. Explain why triangle ABC is congruent to triangle ABC. A prime, B prime, C prime. Okay. Well, you should know that a reflection is a congruence transformation. It is a rigid motion that results in a congruent triangle or a congruent figure. So I'm just going to say that a reflection, and more specifically a line reflection, I'm going to go ahead and actually say that, a line reflection, there we go, a line reflection is a congruence transformation so size and shape are preserved. Therefore, the two triangles must be congruent. You can use those 3 dots, meaning therefore, if that's helpful to your life. Okay, kind of like you use congruent symbol. You can use 3 dots, means therefore. All right, last part 2, I think. Am I losing it or what? Yeah, last part 2. Okay. A flagpole. Oh, excellent. A flagpole casts a shadow. Let's get my drawing tool here and see if I can get, oh, I can't do it there. Darn. Okay, so a flagpole casts a shadow 16.60 meters long. So there's its shadow. Tim stands, so this is 16.60. Tim stands at a distance of 12.45 meters. Here's Tim. Hey, Tim, what's up, man? There he is. From the base of the flagpole, such that the end of his shadow matches the end of the flagpole shadow. Oh, isn't that convenient? Okay. This is just funny. Tim is 1.65 meters tall. Determine and state the height of the flagpole to the nearest tenth of a meter. So my picture is not going to be really awesome here. So to the best of this ability, let's call that a straight line today. And we're going to figure out how high that flagpole is. So this is, you're probably going to want to call it X because I know who you are and how you operate. So that's X. All right, so we're going to find that. Well, looking at this picture, I am right away drawn to the idea that the flagpole better be at a right angle with the ground, and so should Tim. I hope he doesn't walk, like the hunchback, right? So we actually have two similar triangles, which I'm going to, I could redraw, I could do a lot of things here. So I actually want to find X, and I know Tim's height, and then I know the whole length of 16.60, and I don't know the length of Tim's shadow, right? But wait, can I figure that out? Yeah, I have these two numbers. Can I just get this? His shadow. So his shadow is 16.6 minus 12.45. So 16.6 minus, oh, that was a 15. 16.6 minus 12 point, is it 4.5? Say yes, okay. So 4.15. So let's go back here. So Tim's shadow is 4.15 meters. 4.15 meters. So we have a big triangle and a small triangle. This is the flagpole X. This is Tim's height. This is the length of the flagpole's shadow. Shadow is 16.6. And this is the length of Tim's shadow, 4.15. These are right angles. Okay, so I can use a proportion to set this up. I want to know X. That compares with 1.65 is equal to 16.6, big triangle, over small triangle, 4.15. Cross multiply. 4.15 X is equal to 16.6. Do I have the wrong number here? Oh my word, I did something wrong here, but it turned out right. I added an extra number. That was silly. So 16.6 times 1.65 is 27.39. So 27.39. And then I'm going to divide by 4.15. Don't round until the very end. Only round once in any question. So X, which is the height of the flagpole. So I want to divide by 4.15, and I get 6.6. So luckily that was a terminating decimal, so that's really great news. 6.6, and we are in meters. Because I labeled it X in my picture, I can call it X down here. If I don't call it X in my picture, I have to say flagpole. So make sure you label your diagrams. That's all it goes back to. Always label your diagrams. Or else. Okay, so we're officially at part 3s now. When you get to part 3, get your, do your hand stretches because you're going to need to do a lot of writing and words from this point forward, most likely. So this one has an explain, and if you would like to do it in a formal proof or in a paragraph proof, that's all up to you. I'm actually I actually have it, written out as a crazy long explanation. So I'm thinking that actually a column proof would just be easier as an explanation. So once we get started, I think you'll see what I'm saying here. In the diagram below, EF intersects A, B, and CD at G and H respectively. GI is drawn such that GH is congruent to IH. So GH is congruent to IH. All right, well, that tells me a lot of things. So right away, that tells me that GHI is an isosceles triangle because two sides are congruent. And if two sides are congruent, we know that two angles are congruent. So, oh, and today, HI, oh my gosh, I labeled that wrong. Hello. How about there? Is that helpful? Okay. So writing all of that out in like sentences is a little bit stressful for some of you, so you understand the proof aspect in the column way a little bit better. So that means G and I are congruent, which is great news. The other piece of information that they give me down here is that EGB is 50 degrees, okay? And DIG is 115, okay? So I'm going to start kind of working myself through here, because if this is 50, then I know vertical angles, that's 50, but that doesn't really help me. So I'm going to backtrack on that. Okay, well, let's see. We are proving that the lines are parallel. All right. Well, if this angle is 115, I know this angle right here is 180 minus 115 because they're a linear pair, which I'm also going to need to explain. So this is 65, but because this is an isosceles triangle and base angles are congruent, this is also 65. And because I know those two angles, I also know the vertex angle, and 65 plus 65 is 130, so that means there's 50 degrees left for the vertex angle. Ding, ding, ding. These are corresponding. Corresponding angles give me parallel lines. Everything I just said has to be written down. So that's a lot of things, which is why I'm going to do like a statement reason situation here. It's just a really good way to explain, and it's something you're familiar with. So I'm going to start here where I started in the very beginning, statements and reasons. So statement and reason. All right, in the very beginning, the very first thing that I did was mark the given. So it said that GH is congruent to HI, and that was given. I'm going to label that one as well. Okay. So once that happened, I'll draw my line here. Okay. So once I knew that, I said that triangle GHI is isosceles if two sides of a triangle are congruent, then it is an isosceles triangle. Okay, I think we learned that in 8th grade. So then I said, okay, well, if those two sides are the same and it's isosceles, we have two base angles that are the same. I'm actually going to number my angles. This is a fun little trick. This is going to be angle 1, and this is going to be angle 2. Okay? And actually, before I say that those are congruent, I'm going to say that I was given, so let's see, I'm going to add my given up here. Angle DIG is 115, and angle EGB is 50 degrees. I should have all of those in there. So let's see, the measure of angle 2 is equal to 65 degrees. And the reason for that is a linear pair. So a linear pair sums to 180. Okay, well then I know that angle 1 is congruent, measure is equal to the measure of angle 2, because base angles of an isosceles triangle are congruent. Okay, so now I have the 65s. Then I found out that the vertex angle, H, was 50, so I'm going to call that angle 3. The measure of angle 3 is equal to 50. Well, why? The sum of the angles in a triangle is 180. Okay, so then last step, the two lines are parallel. AB is parallel to CD. Why? If corresponding angles are congruent, then the lines are parallel. So you see what I mean? Like if I had to write that all out in a paragraph or whatever, number one, I'm going to miss something. And number two, I'm probably going to talk myself into some circle. And I don't want to do that. I want to keep it organized. I want it to be very clear that I know what I'm talking about. Okay, so let's talk about 33. Now we actually do a proof. So like I said, get your writing hand, all geared up here. So I'm going to change to black writing. Oh, I think I'm on eraser. Sorry. Okay. Given quadrilateral ABCD is a parallelogram. So that's great news. That tells me a lot of things as soon as it says parallelogram. With diagonals AC and BD intersecting at E. Prove that let's see, I'm going to highlight them. AED is congruent to CEB. Cool? All right, I'm going to get the black one. Okay, so I'm going to again do a statement reason situation here. So statements and reasons. Let's get a plan together here. So if I want to get those two triangles congruent, the very first thing I know is it tells me about the diagonals, so I know the diagonals bisect each other. AE and EC are congruent. DE and EB are congruent. Okay. Also, vertical angles are congruent. Okay, so side angle side. If you wanted to use the parallelism of the parallelogram, you could say A is congruent to C. You could say D is congruent to B using alternate interior angles. There's a lot of ways to go here. I'm going to go as simple as I can. You could also use opposite sides of a parallelogram are congruent, which would give me a whole host of ways to go about this. I'm going to do as simple as I can, or what really came to mind here. So statements and reasons. I can't believe I can't draw straight on this. This is just wacky. All right. Oh, goodness gracious. All right, so first thing you want to do is write down the given, right? So let me get in the right location here. Step one. Let's see. ABCD is a parallelogram. And then it told me also about the diagonals. With diagonals, AC and BD intersecting at E. Number one, given. I'm doing a great job. I wrote down the given. You get nothing for writing down the given, by the way. You get nothing for writing down the given. Okay, so first thing I noticed was that in the diagonals, AE is congruent to CE, and I always do layers here. I don't put commas. It makes me crazy. DE is congruent to BE. That is a property of parallelograms. In a parallelogram, the diagonals bisect each other. So then 3. What was the next thing? So that gives me both sides. The third thing I noticed, the third thing I'm going to write down, is the angles at E. So I can number them or I can name them. So if I go up here and I go 1, 2, sorry that my 2 is way over there, 1, 2, I can call them angles 1 and 2. And I don't know where I am now. Okay. Measure of angle 1 is congruent, or no, is equal to the measure of angle 2. Vertical angles are congruent. Okay. So now I have the triangles congruent. I have my side angle side scenario, my side angle side congruence theorem. So for triangle AED is congruent to triangle CEB, side angle side congruence theorem. Okay. Describe a single rigid motion that maps AED to CEB. So first of all, it's a congruence transformation, so you know it's not a dilation. Okay. How are we getting AED onto CEB? So A has to match, so let me get my pen here. A has to match with C. And D has to match with B. So I envision a rotation of 180 degrees. And either way, it would be positive or negative 180 because 180 is halfway. So single rigid motion, I would say rotation of 180 degrees. Actually, let's do this. I'm going to do this last one here. So, the lake question, yay! All right, so we got a lot going on here with this picture. Read carefully, read carefully, read carefully, read carefully, read carefully, read carefully. Okay, did you get the message? Okay, good job. In the diagram below, the line of sight from a park ranger P, I'm going to actually write park ranger here, just so I don't have to, to the lifeguard chair, this is lifeguard. On the beach of a lake is perpendicular, got it, to the path joining the campground and the first aid station. Okay. The campground is 0.25 miles from the lifeguard chair, got it. The straight paths from both the campground and the first aid station to the park ranger are perpendicular, got it. If the path from the park ranger station to the campground is 0.55, determine and state to the nearest hundredth of a mile the distance between the park ranger station and the lifeguard chair. Park ranger station and the lifeguard chair. I'm going to call that, I don't know, X, because I know that's what you like to call everything. All right, so looking at that, I can see right away that's an itty-bitty right triangle, and I'm going to use the Pythagorean theorem. Okay, fine. You could use actually trig if you wanted to, too. So I'm going to use Pythagorean theorem because I think that's what most people will use. So everybody knows a squared plus b squared is equal to c squared, where c is the hypotenuse. So I'm going to say that a is 0.25 and b is x equals 0.55 squared. All right. So I've got to use my calculator and do 0.25. Oh my gosh. I'm going to clear this. Sorry. Doc B. 0.25 squared. And was it 0.55 squared? I need those two numbers. 0625 and 3025. So let's see. 0625. Where's my little 0.0625 plus x squared 0.3025. Okay, Sorry, I looked down, so it got a little wacky. So I subtract that over, and just trust me that I used my calculator and got 0.24. So x is equal to the square root of that. The square root of 0.24 is equal to, so let's go here, the square root of 0.24 is that really, really ugly number. But the directions say to the nearest hundredth of a mile. So to the nearest hundredth is 2 decimal places. So I'm going to write down 3 and then round. So 0.489. Okay, round. If you need 2, look at the third. That's the 9's telling you raise. So 0.49 miles. Almost a half a mile. Okay, so that's great. Gerald believes that the distance from the first aid station to the campground, so he's saying that this whole thing is at least 1.5 miles. Is Gerald correct? All right, well, let's see. If Gerald's anything like Judy, he's not correct. Okay, so we've got a lot of things here. We are actually going to use, we could do that, but that's just wild. We're actually going to use similar triangles here. So I'm going to come down here and I'm going to redraw those triangles. We've got to see who matches with who. So my first triangle, the big right triangle, trying to leave myself enough room too. The big right triangle is the park ranger has the right angle, so P, and then the campground, C, and then the first aid station. And then the small right triangle, which is significantly smaller in my picture, is C, and then L, and then P. Okay, so let's label the information we have. We know that this is 0.55 that was given to us. We know that this is 0.55 because they're the same side. We have that this is 0.49. Because we just found that out. And we know that this is 0.25. So we have all the sides of this one. And we want to find the hypotenuse of this one. Yeah? But if you go up here, that yellow part includes this. So I've got to be careful. I can either write it as y, or we already used x, so I'm going to call it y plus 0.25, or just call it y and then remember to subtract the 0.25 at the end, which is what people probably made a mistake with if they got this wrong. So I'm going to go, I'm actually going to call it y plus 0.25 because the algebra isn't any more difficult. Okay, so we have to set up a proportion. I want to find y plus 0.25. That matches with 0.55. The side that I'm going to use in the big triangle is 0.55, and that matches with 0.25. You get to cross multiply for about the 15th time on this test. So if you're not the #1 expert at cross multiplying, something bad is happening. So 0.25 times y plus 0.25 is equal to 0.55 times 0.55. I don't know why I wrote that like that, so I apologize. So I'm actually going to distribute this, and I know that that's 0.25y plus, I calculated that earlier, so what is it, 0.625? Yeah, 0.625 is equal to I calculated this earlier too, 3025. So I'm solving for y, subtract the 0.0625, and we get 0.24. These numbers are all repeating themselves, right? Divide by 0.25. So y is equal to 0.96, okay? Well, y is 0.96, so C to F is, add the 0.25 on there, 1.21 miles. So I haven't even answered the question yet. Is Gerald correct? Is Gerald correct in saying it's at least 1.5 miles? Well, no. No. Gerald is wrong. So let's write that down. No. Answer it with a yes or no first. The distance is only 1.21 miles. Period. Move on. All right, you've made it to part 4. Take a deep breath because these are usually more involved. And I know you feel like the last part 3s were more involved with 4 points, but these are really, really involved. So make sure you indicate the necessary steps, blah, 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 all of that good stuff. So you have this picture of a water tower. They give you the real picture, and then they give you like the, architectural picture. They want to tell you all the things. The 2-dimensional figure. The water tower is composed of a hemisphere, a cylinder, and a cone. Right away, you should be taking out your formula sheet. You know where those volumes are, so find those. You're going to need them. Let C be the center of the hemisphere, and let D be the center of the base of the cone. So the very first move you're going to make is to label as much as you can in this diagram. So right away, I see that this C to A is 8.5. Well, that's the radius of the hemisphere. So C to K is also a radius of the hemisphere, so that's 8.5. And C to B is a radius of the hemisphere, so that's 8.5. Well, if that distance from the center to the edge is 8.5 at the bottom here, it's also 8.5 from D to F and from D to G. So I have a lot of 8.5s floating around, right? Then it says really nothing else. It doesn't tell me anything else. I should know that, well, this is 47. That's really not a big deal. Okay, so we've got all that. Oh, we have this 25. That's where I was looking, which means this height in the center is 25, which means G to K is 25. I don't know if I'm going to need all these numbers labeled out like this, but I probably will. Okay, so I have to figure out, let's see, if I turn the page, it says that the question is continued. If AC is 8.5, BF is 25, and measure of angle EFD is 47, determine and state to the nearest cubic foot the volume of the water tower. I'm actually going to do it on this side. You have the picture on one side and on the right. There's a lot going on here. So first thing is the top is a cone. So the volume of a cone is equal to 1/3, this is straight off your formula sheet, pi r squared times the height of that cone. So the volume of the cone is 1/3 pi. The radius is 8.5 squared times the height. But wait a second. Do I have the height of the cone? No, I don't have the height of the cone. I've got to find the height of the cone. What is the height of the cone? So I've got to figure out E to D. In order to do that, I've got this little mini right triangle. So this is a little right angle. I want to know E to D. I'm going to call it, I don't know what I called it in here. I think I called it H, the height of the cone. But I think I use H again later, so I don't want to mess you up. So I'm just going to call it X, right? That's your favorite? So I want to know the opposite side, and I know the adjacent side, which means I want to use SOHCAHTOA, and opposite and adjacent tells me to use tangent. So I'm actually going to show this work on this page, but up here a little bit. So tangent of 47 degrees is equal to opposite, X, over adjacent, 8.5. In order to get that, I'm going to cross multiply. So X is equal to 8.5 times the tangent of 47 degrees. Okay? I wish I didn't call that x. So if you type this into your calculator, let me show you. It's going to give you an ugly decimal. So let me clear this. Doc B. What did I just say it is? Oh my goodness. 8.5 times the tangent of 47 is that ugly decimal. You don't want to round. You can't round until the end. So you need to store that. Don't ever store for x is my advice to you. So I'm going to store that. What letter have we not? We're not going to use... R and H are busy, right? Radius and height. So I'm just going to pick K. I like to store things for K. Okay, so now it believes that K is that. Got it. I'm going to use that later. Or, well, in a minute. So I'm going to call this K. So K is equal to that number, and it's stored in calculator. Just writing that note there. All right. So down here, when I have that height, I've actually stored that for K in my calculator. So that's a bold K. So the volume of the cone is equal to, let's go here, 1/3 pi r squared is 8.5 squared times K, right? That's going to give me a really big number again. So wait a minute. I'm going to keep that in there. You just wait a second. I'm going to leave that right there. That's going to be a really crazy number. So the next thing I need to actually figure out is the middle, right? The middle is the volume of a cylinder. I'm going to see how my spelling is going today. And the volume of a cylinder, right from your formula sheet, is pi r squared times the height of the cylinder. So pi radius is 8.5 squared. The height of our cylinder was 25. I'm going to leave that there because I'm going to get an ugly decimal. I don't want an ugly decimal. I use blue. The bottom of the tower is the volume of a hemisphere. Now, you have to know that a hemisphere is half of a sphere. So I'm going to do 1/2, 4/3 pi r cubed. And that, again, that's straight off of the formula sheet. So 1/2, I know this looks ugly. Don't you worry, your pretty little head. Pi radius is 8.5 cubed. Again, this is also going to give me an ugly number. My goal is to find the total volume. So my goal is to add up this and this and this to get a total volume. Total volume. That number, I don't know what word I just wrote, by the way. It looks like something weird. We're going to round to the nearest cubic foot. Okay, so I'm going to type all of this in at once, which is kind of awesome. So, all right, so we have the cone. Then we're going to add on pi r squared h. So pi r squared, 8.5 squared, and a height of 25, plus 1/2, I'm going to do 0.5, then I'm going to do control divide. 4/3 pi r cubed, 8.5 cubed. Now, you could have also stored 8.5 for r, so typing this whole shenanigans in would have been way easier. I don't know why I didn't, to be honest. That was kind of silly. All right, so I get this whole crazy number. To the nearest cubic, what are we doing? Cubic, what are we doing? Feet? Cubic foot, there we go, found it. So 7650.3 rounds to, so let's be good about our work here. Where is it? 7650.3 to the nearest cubic foot would be 7,650 feet cubed. So there's the total volume. You had to show all of that work. You don't have to show out the ugly decimals, but you can't round more than once. So I would do it all in the calculator or get those numbers and store them in the calculator somehow and then use them. All right, so let's scroll here. Okay, the water tower was constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? That's still not, right? Ugh. Justify your answer. Well, we got three numbers thrown in here. The maximum it can hold is 400,000. So if our number goes over 400,000, we got a problem. 62.4 pounds per cubic foot. Well, I have 7,650 cubic feet, so I'm going to multiply those numbers. So 7,650 cubic feet times 62.4 pounds per cubic foot, right, equals, okay, so let's go to the calculator. So 7,650 times 60, I can't remember from 1 second to the next, that's terrible, 2.4 is 477,360. But the one number we didn't use was the 85%. So hold on 1 second. I can't get this silly thing. So 85%, well, there's two ways to do it. I could calculate the 85% before, so I could do 85% of this, or I can do 85% of the number I just got, which I don't remember what it is, so I have to use my mouse. 477,360, 477,360, 477,360. Okay, I need 85% of that. So times 0.85. Percent means out of 100. So 85 out of 100 is 0.85. So now I'm going to take that number and multiply by 0.85. So times 0.85. 405,756, which is equal to, oh no, what did I just do? Sorry. 405,756. Okay. Is that greater than the 400,000 pounds it can hold? Well, yeah. So, if water weighs this, can it be filled and not exceed? Well, no. No. It will exceed the limit by, that's a really ugly B, I apologize, 5,756, and it must be pounds. Okay, so you can calculate the 85% of the volume first or after you multiply. Because I was going in order with the numbers there, I did it after, which was okay. And my answer key, I did it first, so either way is fine. Okay, last question, I hope. Yeah, okay, it's just long, it's just 2 pages again. In the coordinate plane, here are the vertices of RST. Prove that it's a right triangle. All right, coordinate geometry proofs. You have to be the master of the universe. Step 1, plot your points. Nailed it, okay. Step 2, state the facts. Step 3, calculate whether it's slope or distance or whatever. And step 4, summarize. Those are really the basic steps to a coordinate geometry proof. Obviously, you want to plot the points. So I'm going to go here. R is 6, -1. Let me find out where I am. 1, 2, 3, 4, 5, 6, -1. There's R. S is 1, 4. I hate when that happens. S, and then T is negative 5, 6. 1, 2, 3, 4, 5. I don't know if I counted right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, S is 1, negative 4, Newman. That was dumb. That's what you get, right? 1, negative 4. 1, 1, 2, 3, 4. S. There we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Sorry about my faces. I really make a lot of faces and I know it. All right, so we have this triangle and they want us to prove that it's a right triangle. So what comes to my brain is just perpendicular lines. So I'm going to be using slope here, but I'm just thinking about that as I connect the dots. Oh, sorry, that was a terrible, terrible line, but I'm doing the best I can here. I'm glad I thought to use the drawing tool because this is a little rough, isn't it? Okay, let's pretend that that's really good. And let's think about which one of these we think is a right angle. I'm going to guess that it's S. I don't know if you agree with me or not, but I hope you do. So the next thing you want to do is state the facts. What do we know, or what do we need to know in order for it to be a right triangle? What do we know about a right triangle? So state the facts. In a right triangle, one pair of sides is perpendicular, forming a right angle. Isn't that the fact that we know? Yeah, okay. So that's the fact. We also know that perpendicular lines have negative reciprocal slopes. Okay, so that's going to be the dead giveaway of what calculations I need to do. So that's why I like to state the facts first. What do I need to know? What am I trying to do here? Say all the things you need to say, because then it'll lead you to what math you need to do, what calculations. So the slopes. Okay, the slope, I'm not in the right place. The slope of R to S is 3/5, and I just did that by rise over run. The slope of S to T is negative 10 over 6, which reduces to negative 5 over 3. And the slope of T to R is negative 7 over 11. Okay, so I'm looking for negative reciprocal slopes. Right here, I can see that those are negative reciprocals. So I can say that RS is perpendicular to ST because they have negative reciprocal slopes. Angle S is a right angle, so triangle RST is a right triangle. Now the reason I don't have to back that up now, I don't have to say this because of this, and this because of this, and this because of this, it's because I stated all the facts in the beginning. So now I can just say, hey, these are all true things. In this situation, this is what happened, so I have a right triangle. Now it wants me to state the coordinates of P such that quadrilateral RSTP is a rectangle. Oof. All right, so I want to go to my graph this time. So I'm going to go back over to here. State the coordinates of P, and then we have to prove. Okay, So where would we put P? Well, P, if there's a right angle at S, where's my little tool here? If there's a right angle at S, then there's going to be a right angle opposite of that. So at P, wherever. So I've actually got to figure out where it is, but as you can see, I've kind of have an idea that it's in that area. I have to use the slope. So the slope from S to R is up 3 to the right 5. So I'm going to go up 3 from T to the right 5. 1, 2, 3, 4, 5. Oh, right there. P ends up right here. So P is the point 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 9. So that we have a rectangle. Now, how do I know it's a rectangle? Well, one, because I drew it there. But because these are going to be negative reciprocal slopes, and the opposite angles are 90. So we should be all good here. Let's see. Yeah? Okay. In a rectangle, you have 4 right angles. I'm going to guess that's how most kids would do it, or 2 consecutive right angles and parallel sides. There's a bunch of ways to go about it. You could also say that the diagonals are congruent. So I could draw diagonal PS and say that those are congruent. I can do this a bunch of different ways, but I'm actually going to, because I have all the slopes, I'm just going to use my slopes and say I've got perpendicular sides 4 times and call it good. So I've plotted all my points. That's step 1. Step 2, state the facts. Okay, in a rectangle, all angles are right. So consecutive sides, there's a good one, are all perpendicular. Okay, so the slope of RS is still 3/5. We used that. The slope of ST, we calculated that, was negative 5/3. The slope of TP and the slope of PR, I've got to do those two. So T to P, we mirrored that with SR, so it's up 3/5. Uh-oh, I think I'm stuck. Oh, there we go, up 3/5. Okay, so up 3/5. And then P to R is down 5/3. So as we can see here, negative reciprocals, they're paired together, negative reciprocals, negative reciprocals, and negative reciprocals. So I can say RS is perpendicular to ST. ST is perpendicular to TP. TP is perpendicular, that was terrible, sorry, RP, I guess, because I made a boo-boo there. And PR is perpendicular to RS. This should say PR, sorry. Therefore, RSTP is a rectangle. Like I said, there's other ways to do this. A lot of times I'll do it the way I think a kid wants to do it, or the way I see it most often with students. The middle of the roadway, not like the, oh, I'm such a genius, I'm going to do it this way because it's the fastest and the shortest, or the kid that goes around in a circle. I'm trying to do what I think a middle of a road average kid would think. So that's what I think an average kid would think about. And I labeled the point on there. I should probably write it here as well. So P is 0, 9, just for good measure that I have that written out. And that's it. So follow us on YouTube. If you need construction links, go back and find the link at the bottom after the construction question, which I believe was the 2-pointer, number 25. And come back and see us. More exams coming soon. Hopefully we'll see you again. Thanks for watching.